Hello there. Today we're going to go over some graphing notes. Graphing is a skill that we're going to use all throughout the year in AP Physics. It comes up in just about every unit throughout the year. So we're going to take some time here at the beginning of the school year and talk about some of these graphing skills to make sure you're ready to go for AP Physics. And so before we get started, the first thing that you need to make sure you get is you need to have some graphing paper. And so when you graph, you don't want to graph just on some blank piece of paper. Okay, without the graphing lines, you're not going to end up with an accurate graph, and it's going to cause you to pull some inaccurate data from your table or from your graph. And the next thing you need some kind of a straight edge or ruler. So when we graph, we make what's called a best fit line. And so in order to do that, we're not going to hand sketch that line, but we're going to use a straight edge ruler and we're going to draw that line. So make sure you gather those two things before you start graphing. And then once it's time to start graphing, what's going to happen is you're going to have some kind of a data table, or you're going to pull some data from an experiment or something like that, and then you're going to graph it. Okay, so let's say, for instance, you're given some data for a position and time. Okay, so we'll say X, that's for in meters, and that's my position. And let's say I was also given some time, which is in seconds. And let's say for our position, it was 2 meters, 4 meters, 6 meters, 8, and 10. And let's say my seconds were 1, 2, 3, 4, 5. And then we wanted to graph this data. So the first step is you want to always label your axes. Okay, so in math class, we have X and Y, right? We always have our Y axis and we always have our X axis, and we just leave it like that. But we're in physics, okay, so now this X and Y is going to actually represent something. And so for this case, we have position and we have time. Now, your time is usually always going to be on your X axis. So I'm going to label my X axis time, and then I'm going to include a unit, okay, in parentheses, seconds. So you always want to label it with the unit and the variable. And so up here we have position, and that's measured in meters. Okay, it's important to include that unit of measurement. And then once we do that, then we're going to come up with a scale. In our scale, what we want to do is we want to stretch out our graph as much as we can and use majority of the graph paper. So for example, for the time, what I don't want to do here is I don't want to say 1 second, 2, 3, 4, 5. Because now when I graph it, all of it is going to be squished right here. Okay, and we don't want to do that. We want to stretch it out as much as we can. So for this graph here, what I would do is I'd probably skip a line, right? So in other words, every line is about a half second. So I'd have 1 second, 2, 3, 4, 5. And so I stretched it out quite a bit. And then now for the next one, for position, since it goes all the way up to 10, then we can probably say every line is 1. Okay, so what I don't want to do is say 2, 4, 6, 8, 10, because then again, it's all squished right here. You want to stretch it out as much as possible. So I'm going to say every line is 1. So then I'll say 2, 4, 6, 8, 10. So again, before you get started, you want to make sure that you labeled your X and Y axis with whatever it is you're graphing, and then come up with a scale for your graph. Then the next step is just to plot your data points. Okay, so for the first one, you have 1 second, it's 2 meters. I'll put a dot there. 2 seconds is 4 meters. 3 seconds is 6 meters. 4 seconds is 8 meters. 5 seconds is 10 meters. So now we've graphed our plotted our data. And then the next step is we want to make what's called a best fit line. Okay, so your best fit line is going to be an average of your data. Now this one's nice and easy. Okay, so all we would do is we'd get our ruler and line it up where the average of all our data points are, and then we would draw a straight line. Okay, so draw a straight line. There we go. So there's our line. Okay, and so this one was nice and easy because all the data points were even, but that's not always going to be the case. Okay, sometimes you might end up, let's see if we can draw this here. And let's say, for example, everything wasn't nice and pretty. Okay, let's say that our data points did something like this. Okay, so now obviously these lines, the line here, it's not going to hit all the points like in the last one. So what you would do is you would get your ruler and you would line it up where the majority of your points lie. So it looks something like this. Now, if you notice, the best fit line didn't touch any of those data points, and that's fine because this best fit line, it represents that average of all your points. And if you notice, it didn't go through 0, 0. And that's okay. Okay, it doesn't have to go through 0, 0 there. Okay, because again, it's an average. Now, the next step that you want to do after you've made your best fit line is we're going to find the slope of that line. Okay, and so to find the slope, remember we find 2 points, right, and we plug it into our formula for slope, and if you remember from math, it's the change in y over the change in x. Okay, so that is equal to y2 minus y1 all over x2 minus x1. So this little delta here is just means change, right? So it's a change in y over the change in x. So when you find the slope of a line, you never use these data points, okay? The reason why is, let's say on this graph, I had a data table and I just picked 2 random points. Let's say those 2 points I picked were here and here. If I looked at my data table and I said, oh, those would be easy to work with, and I plug them into this formula up here, and I find the slope, well, what I've just done is I found the slope of a line that would go through those 2 points that would look something like that. And you can see that line is nothing like our best fit line that we had made. So you never want to pick just random points from your data table. Okay, instead, you want to pick points that are actually on your best fit line. So in this example, I would pick a point, let's say around here and here. And you circle the points and you can find the slope. So back up here, since all of these points went through the best fit line, okay, because we kind of have an easy example here, it doesn't really matter, right? Let's say we put here and here. And then we're going to plug it into our formula for the slope. So your slope of this line is going to equal your y2 minus your y1, which would be 6 minus 4, all over your x2 minus x1, which would be 3 minus 2. Okay, so 6 minus 4, that would give me 2. 3 minus 2 would give me 1. Now, here's the thing that's also different than math. The x and y actually mean something, right? They're not just numbers. So you want to make sure and you include the unit. So my y, we said, was meters. So this should say 2 meters. And my x was seconds. So I'd want to say 1 second. Okay, you always want to include your units here. And that would give you 2 meters per second. So there's my slope. And then the last step is we're going to put it into the equation of a line. And if you remember from math class, the equation of a line is y equals mx plus b. Now again, we're in physics. Okay, so we're not going to use just y and x because now these things mean something. And so my y was position. Okay, if I look back up here, it's position. So instead of y for this equation, I would say x equals m is your slope, and we found it right here. So I would put 2 meters per second. My x variable is time. So I'm going to put t. Okay, so we're using the same formula that you did in math, but now your y and your x actually mean something, whatever it is that you're graphing on your graph. Okay, so you substitute those. Oops, right here. Plus b is your y-intercept. Now this first one was a nice easy graph, so it went through the 0, 0 there, so my y-intercept is just 0. So your final answer for this one would be x is equal to 2 meters per second t. So there's a lot of similarities from your math class, right? You use the same equation for slope, use the same equation of the line. It's just now your x and y mean stuff, okay? This one here was a position time graph. We're going to see a lot of different types of graphs in physics. So you always want to make sure you label your x and y axis whenever you're graphing.